This video here we're going to be looking at adding and subtracting like terms. So hopefully you know what like terms are by the end of this lesson, and that you can simplify expressions by adding and subtracting those like terms. So firstly, what are like terms? And I'll get you to write this down. Like terms are terms whose pronumerals are the same. So the example we've got there, we've got 5a and we've also got 7a. So if we did a drawing of this, we've got 5a and 7a. You'll see that the pronumeral is the same in a in both. So they're an example of a like term. We also have ones in which they might have a power, so b squared, etc., or 9b squared and 4b squared. They are also like terms. So three things that like terms should have or can include, and I'll get you to write these down. The first one is constants. So constants, as we've seen before, usually numbers. Okay, so in this case, you'll see the numbers there. They have constants. Now, terms with the same pronumeral can be in a different order. So by that I mean you can have 5ab and 7ba. They are actually like terms. So we know, for example, let's just say a was 1 and b was 2. 1 times 2 is also the same as 2 times 1. Doesn't matter what order you put it in, you'll also get the same answer. So even though they look different, they are like terms despite the different pronumerals being in a different order. You also can have terms with the same pronumeral raised to the same power. So our example here that we've got b squared for these two. They are the same pronumeral and it's raised to the same power. And that's the key thing there that you need to make sure that you understand. So let's look at a few examples here. We've got a couple of pairs here, and we want to see if they fit the rules for like terms. So we want to determine if the following are like terms. So we have 5abc and negative 8bc. And it's a pretty simple one. They all have the same pronumeral. They're all in the same order. It's kind of easy to determine that one. So yes, these ones are like terms. For the next example, we have 12xy squared and 4y squared x. Now these are both like terms, and I'll explain why. So we have our y squared, and this one is y squared as well. So they do have a pronumeral to the same power, and they also have an x. And again, it doesn't matter what order they are in. In this case, they both have the same pronumeral and also the same pronumeral, which is to the same power. So these both are like terms. Now the other example here, we have 3ab squared and 7a squared b. Now yes, they do have a power, but you'll notice that they're above the different pronumerals. So if we expanded this, we wrote this out in expanded form, we'd have 3 times b, because it's b squared. And this one would be 7 times a times b. And when we've put it in expanded form, you can see the difference that this one has 2 a's in it, where this one only has 1. So they are not like terms, okay? And when we've put it in expanded form, you can actually see how that works. Now the reason we want like terms, or the reason we can use like terms, is that we can actually combine them and we can simplify an expression. I'll get you to write this down. So like terms can be added and subtracted to simplify an expression. And as always, remember that the sign stays with the term, so the subtraction or the addition, etc. So what we're going to do here is we're going to show you how we can actually combine those like terms to simplify an expression. So the first one we have here, first thing you're going to do is look for the like terms. You want to group them together. This one's a pretty easy one, as they all have the same pronumeral t. They're all like terms. So all you need to do is just go through the process or evaluate. So 7t plus 2t equals 9t, minus 3t will equal 6t. Okay, so we've simplified that expression. So that expression can be written the same way as just 6t. We've combined our like terms. Now when we get to a little bit more complex ones, what you want to do is, as I've said before, you want to sort of combine the like terms together. So as I look through here, I know that I've got a 3y and a 7y. And I've also got a 4x and a 2x. So I want to combine them so I can now start to create a simplified expression. So I have 4x plus 2x, okay, so I've got these two next to each other, plus 3y plus 7y. And now I can actually just go through the process of combining them. So really this is saying 6x plus 10y. So instead of this expression here, I've been able to simplify it by combining the like terms to 6x plus 10y. Now we can also get some very more complicated ones, as we can see here. So again, I'm going to look through and find for the like terms. And I've noticed here, once I've looked closely, I have 7ac, but we also know the rule that it doesn't matter what the order the pronumerals are. I've also got negative 2a, and as you can see, I said negative because we need to combine the symbol that goes along with it. So they're actually like terms, 7ac and negative 2ca. I can also combine these ones here. Okay, we have 3b, 4b and minus 5b. So now I'm going to write this out in them together. So I have 7ac minus 2ca plus 3b plus 4b minus 5b. And now I can combine them to make a simplified expression. So I have 7ac minus 2ca. Now that will be 5ac. Now you can also write 5ca. It doesn't necessarily matter which order you put that in, but 5ac for the sake of this question here. So 5ac because I've combined them. Now I have 3b, 4b minus 5b. So I have 7b minus 5b. So 7b minus 5b is 2b from there. So now I've combined those two together. I've created a simplified expression. As you can see, this looks quite complicated, but when you bring it down to a simplified expression, it looks much easier. And as always, if you have any questions, please write them down so we can go through them in class and be able to delve into them a bit deeper. Thanks, guys.